In this video, we will discuss measures of location with the following subtopics: mean or arithmetic mean, median, mode, geometric mean. Measures of location using mean or arithmetic mean. This is the average value for a variable. It provides a measure of central location for the data and denoted by x bar for sample data. Here n is the sample size, x1 is the value of the variable x for the first observation, x2 the value of the variable x for the second observation, and xn is the value of the variable x for the nth observation. This table shows data on home sales in Cincinnati, Ohio suburb. Computation of sample mean. Illustration. Computation on the mean home selling price for the sample of 12 home sales. The mean is equals to x1 plus x2 plus up to x12 because there are 12 sample data all over 12 because n is 12. So we have a total of 219 and 219,937.50. Measures of location. Median. The value in the middle when the data are arranged in ascending order, and the middle value for an odd number of observations. It's the average of two middle values for an even number of observations. Example, when the number of observations are odd, consider the class size data for a sample of 5 college classes: 46, 54, 42, 46, 32. Because n is 5 and 5 is odd, median is the middlemost value in the data, which is 46. We can arrange the class size data in ascending order, and the middlemost value in the dataset is 46. So median is 46. Computation of sample median. Example, when the number of observations are even. Consider the data on home sales in Cincinnati, Ohio suburb. Arrange the data in ascending order. The median is the average of two middle values. The two middle values in these even observations are 199,500 and 208,000. Divided by 2, then we get 203,750. Measures of location mode. The value that occurs most frequently in a dataset. Consider the class size data 32, 42, 46, 46, 54. Observe 46 is the only value that occurs more than once. Then the mode is 46. Multimodal data is the data contain at least two modes. Bimodal data, that is data contain exactly two modes. The mean can be found in Excel using the average function. The value for the mean in cell E2 is calculated using the formula equals average B2 colon B13. The median of a dataset can be found in Excel using the function median. The value for the median in cell E3 is found using the formula equals median B2 to B13. Measures of location geometric mean. Nth root of the product of n values is used in analyzing growth rates in financial data. In this table, we show percentage annual returns and growth rate factors or growth factors for the mutual fund data. Example, consider the percentage, annual returns, and growth factors for the mutual fund data over the past 10 years. We will determine the mean rate of growth for the fund over the 10-year period. Solution: the product of the growth factors are the following: equals to 1.335, and geometric mean of the growth factor is 1.029. Conclude that annual returns grew at an average annual rate of 1.029 minus 1 times 100%, or 2.9%. In this figure, the value of the geometric mean in cell C13 is found using the formula equals geomean, geomean open parenthesis C2 colon C11. Measures of variability. We have the following topics: range, variance, standard deviation, and coefficient of variation. In this table, we have the annual payouts for two different investment funds. And the figure 2.18 are the histograms for payouts of past 20 years from Fund A and Fund B. Computation of range. The range is found by subtracting the smallest value from the largest value in a data set. Example, consider the data on home sales in Cincinnati, Ohio suburb. The largest home sales price is $456,250, and the smallest home sales price is $108,000. The range can be found by subtracting the largest value and or the smallest value from the largest value, or largest value minus smallest value. That is equals to 348,250. The drawback of range is that it is based on only two of the observations, and thus is highly influenced by extreme values. Measures of variability variance. The measure of variability that utilizes all the data. It is based on the deviation about the mean, which is the difference between the value of each observation, or xi, and the mean. The deviations about the mean are squared while computing the variance. This table shows the computation of deviations and square deviations about the mean for the class size data. First column, we have the number of students in class, and second column is the mean class size, which is 44. Then the third column is the deviation about the mean. Fourth column is the square deviation about the mean. Then the computation of the sample variance S squared is equals to 256 all over 4, that is equals to 64. Calculating the variability measures in Excel. The range can be calculated in Excel using the max and min functions. The range value in cell E7 in this figure calculates the range using the formula equals max B2 colon B13 minus min B2 colon B13. This subtracts the smallest value in the range B2 to B13 from the largest value in the range B2 to B13.